Okay. So my name is Martin Barbour, I'm from QSC Audio. I would like to introduce you to the Q-SYS Core 500i platform. So this is our newest processing engine. One of the things that sets Q-SYS apart from other products in a similar product category is that we have moved away from proprietary DSP technology. So we are embracing IT hardware and operating systems. So the Core 500i itself is an Intel processor. So we're running the latest Intel motherboard and processing chips, and we run Linux as our operating system. So from a hardware platform perspective, it's probably one of the most tried and tested and resilient hardware engines available. It's running businesses all over the world. What we do is we use that Intel processing engine to run our QSC Audio processing algorithms on board. So we don't need DSP chips, we do everything on the Intel processor itself. One of the things that gives us is a huge amount of processing power, I mean far more than is available with any other proprietary DSP platform available. It also enables us to take advantage of the IT industry as it moves forward. Q-SYS was launched originally 3 years ago on a completely different hardware platform based on Intel server chipsets. Well, now just 3 years on, we've already moved on to our second generation platform, and that's offered us higher power at lower cost. And that's something that we aim to do moving forward, and we can take advantage of the IT industry. Additionally, with regards to, aside from processing, purely on the networking and the integration perspective, again, we're really embracing the IT industry. Everything we do with Q-SYS is completely IT standards based. And that puts us in a unique position when it comes to integrating with building networks. Our system was designed specifically to be able to integrate with converged network environments. So some of our largest projects are already based on single networks running everything from CCTV, voice over IP, access control. Everything in the building is running on this converged network, including Q-SYS. And that's only possible because we are genuinely IT standards based from a hardware and from a networking standpoint. So we are working at layer 3. IT professionals around the world understand our protocols because we're using the exact same protocols that they use every single day. One of the other advantages of being based on the Intel platform, as I mentioned already, is the processing power. We've been able to utilize that just recently with our latest edition of our latest firmware change. So we've moved to version 3 of our software platform, and what we did with that was we unlocked and added our AEC processing algorithm. So acoustic echo cancellation, which is typically an extremely demanding processing requirement with any DSP platform. Because we're running on Intel, we're able to leverage the power of the Intel platform and offer it as a built-in processing component. So where everybody else has to charge for expensive DSP chips to do AEC, it just comes as a free upgrade with Q-SYS. So now every system running Q-SYS around the world, by upgrading to the latest version of firmware, gets built-in echo cancellation for free. Again, based on the fact that we're IT standards based, we're able to take advantage of remote diagnostics against IT standards based. So we can remote dial into Q-SYS from anywhere in the world over a 3G dongle as an example, just using IT standard VPN connectivity. But what's really unique about our approach to it is, again, because we're using IT standard networking, not only can we see and diagnose and have a look at the system, we can also remotely listen to the system. So from anywhere in the world, using a standard 3G dongle, I can dial in and listen to the audio system and help people service and understand and diagnose problems from anywhere in the world. So if you're a contractor and you have a service contract with a project, it saves you a huge amount of cost in terms of travel, time, and being able to remote support your customers. The system will also generate email reports, so you can alert you to problems before the customer ever even knows about it. From a safety perspective, again, without wishing to sound like a broken record, IT standards based, we can take advantage of all the standard hot swap IT-based redundancy platforms. So we've got, if you think about our processor as though it was an IT server, we support IAM hot swappable servers, so we can have 2 of them on the network, they're duplicated, and they support each other. If one fails, the backup one takes over automatically. And that's true of all of our processors, input outputs, networking, page stations. So we have redundancy throughout the entire platform. including the amplifiers, which form a really big part of this. So if you look at an entire system, we would typically have a processing engine at the center, so we have a centralized processing block. We then would distribute I/O devices around the building. We distribute page stations and also touchscreen controllers. And these all live on a standard gigabit IP network. So from an architecture standpoint, it's very simple to deploy, it's very simple to design with, because you only have to think about one processor. And you distribute inputs, outputs wherever you need them. From an energy saving sustainability perspective, again, the fact that we only have one processing block makes things more cost effective from a raw materials perspective. And again, the fact that we are able to implement and integrate directly on a converged network means that, again, the customer is not paying for multiple networks inside their venue to support IT standard stuff and proprietary stuff. If you can put everything on a standard IT platform, you can use the built-in network. And that's one of the biggest selling points and one of the biggest things that our customers are taking advantage of. Some of our biggest systems are built on complete converged network environments. So specifically on the Core 500i, we have 32 channels of onboard I/O. So if your system design requires no more than 32 audio channels, then a single core processor will do that. And then we can, if need be, we can add additional I/O frames up to 160 to support those networks. So from a cost perspective, you buy a processing engine and then you can very easily add multiple I/O devices as your project grows. So it's very much a forward-thinking approach to system design. Talking a bit quick, I guess I probably covered most of the topics that I wanted to. Are there any things you'd like me to discuss in more detail?
The audio transport itself, how do you do that?
The audio transport system? Yeah. Okay, so we're using the exact same protocols as the IT industry is using for live audio transmissions, such as VoIP telephony. So we're not using, we call it QLAN, but actually QLAN is just our name for standard gigabit IP networking. Everything we're using is completely open and accepted IT standards. So when we go to a project and we're trying to integrate with a network, we provide our white paper, which discusses the protocols we use, and it's the sort of thing that the IT guy is using every day on all of his other systems. So he doesn't have to learn anything new. It's just standard IP networking.